All right, everybody. So today we're going to be talking about two different concepts, and they're both different tools that we could add to our stoichiometry toolkit. Okay, so first thing that we're going to talk about is before we've been going from mass to moles, moles to moles, moles to mass. But today we're going to be talking about how to do the number of atoms. Okay, so the key is you always have to get into moles and then out of moles. So we're going to talk about this conversion right here or this conversion right here. That's not to say if you can't go to atoms to moles to moles to mass, you can. So let's go ahead and put that into our notes. These, by the way, you need to import. So number atoms A, and we can now get into number atoms B. Okay, cool. So the main way to do this is Avogadro's number. Okay, and this is 6.02 times 10 to the 23rd. So that's a huge, huge, huge number, and it's the number of atoms that or molecules in a single mole. Okay, so for Avogadro's number, let's go ahead and write that in here, 6.022 times 10 to the 23rd atoms per mole. Atoms or molecules per mole. Okay? Okay, so it's just a simple one-step conversion, but we could also use it in bigger questions. So let's start with this one. If you start with this many atoms of carbon, how many moles of it? Okay, so this is the problem that we're going to be doing right here. So 2.105 times 10 to the 24th atoms of carbon. And I want to know how many moles of carbon that is. Okay, so basically I'm going to be using this conversion factor right here, the Avogadro's number. And this is 6.022 times 10 to the 23rd atoms for every 1 mole. So basically I can go with here, atoms on the bottom and mole on top, and everything will cancel out. Now I can leave carbon here because carbon's going to stay. So the number is 6.022 times 10 to the 23rd. So I'll take that number right here and I'll paste it right in here. Except for I'll make it a bit smaller, like that, for every 1 mole. Now we get to a part where we have to do a bit of math. So there's 2 ways to do this scientific notation. Okay, I'm going to show you the first one real quick. So basically what I want to do is the math part of this, which is 2.105 times 10 to the 24th times 1 and then divided by this. So it's using the EE button. The EE button is right here. Also, I made a little thing. If you're using a scientific calculator, it looks like that. Okay, and what the EE button means is times 10 to the. So basically what I'm going to do is for this one right here, I'm going to say 2.105 EE 24. Okay, so see how that EE represents times 10 to the? And then I'm going to divide that by 6.022 E23. And I get my answer right here, which is 3.5. Okay, so this one right here was a one-step problem, but let's go ahead and look at it, what it would look like in a bit more of a complex one. So we're going to use this classic one, hydrogen gas combining with oxygen gas to form liquid water. And first thing you have to do, like always, is you have to balance it. So I'm going to give it 2 here, I'm going to give it 2 here, I'm going to give it 1 here. So let's see here. I'm starting with 1 times 10 to the 24th molecules of oxygen gas, okay, O2. So molecules O2. And it is asking me how many grams of water will form. Okay, so I want to know grams of H2O, grams of H2O. Cool. All right, so let's go ahead and start this thing right here. I'm going to say my oxygen gas, 1.25 times 10 to the 24th. Put that right in here. And I want to get grams H2O over here. Right? Right. Okay, well, let's see here. We're going to go from atoms to moles, moles to moles, moles to mass. So I need to get molecules on the bottom here and turn it into moles, molecules into moles. And I'm just going to leave it like that. And then right here, I'm going to say, okay, well, I want to have moles of O2, and I want to get into moles of H2O, because that's what the substance, my final substance is. And then once I have moles of H2O, I can get it into grams of H2O with a little bit of a side hustle. Cool, cool. So the next thing that I have here is I am going to fill in what I know. And I know I have Avogadro's number right here on the bottom again. So 6.022 times 10 to the 23rd. I look at my balanced equation for this, and I have a 2 in front of my water and a 1 in front of my oxygen. And then over here, I can do my side hustle for water. There's 2, there's 1. Each one of these weighs 1.008. This one weighs 15.999. I have these memorized, but you can definitely use the periodic table. 2.016, 15.999, and this is 18.015 grams per mole. Cool, cool. So I can take this number right here and I can put it in right here, and I am ready to go. Okay, so what I'm going to do here is I'm going to say 1.25 E24, that's this number right here, times 1 times 2 times 18.015. And then I'm going to divide it by 6.022 E23. And that is my answer, 74.8 grams. Cool, cool. The second bit I want to talk to is molarity. And I like to think of molarity as concentration. So if you take a little bit of salt and you put it in some water, it's not going to be very concentrated, not very strong. If I take a lot of bit of salt and I put it in some water, it'll be stronger, right? So it's what we're going to be talking about is volume today. So volume A, and mostly volume of liquids. We'll talk about volumes of gas later, but volumes of liquid, okay? And basically the first thing that you need to know is that what molarity means. So molarity is how many moles per liter, okay? Liter, by the way, we use an ELF like that. All right, and it's a unit of measurement. So something with a really high molarity, like 8 molar, is going to be really concentrated, while something kind of low, like 2, is a low concentration, okay? So 4 moles divided by 2 liters is 2 molar. So that means there's 4 moles for every 2 liters. That's 2 moles per 1 liter. Or 0.8 moles for every 2 liters is 0.4 molar. And another thing that you need to know is that 1 liter is equal to 1,000 milliliters. And this will really help us when we're doing lab work, because we don't really have enough to do with 1 liter. So first one right here is, if I have 850 milliliters, how many liters is it? So I have 850 milliliters, and there's 1,000 milliliters for every 1 liter. And all I do is go like this, multiply and divide, and it's 0.850 liters. Pretty simple stuff, okay? Another way to kind of remember this is that this right here is, I'm moving it 3 spots to the left, 1, 2, 3. Let's look at this one though, slightly more complicated. So if I start with 2 liters of 0.25 molar HCl. Let's think about that. 2.5 molar. That means moles per 1 liter, right? That's what molar means. So basically, I can kind of use this right here as my conversion. So it'd be 1 liter on the bottom and 2.5 moles on top. And 2 times 2.5 is 5 moles. Cool? Cool. The last one is a bit more complicated and more like kind of how we're going to be doing in our homework and everything. So if I start with 400 milliliters of 8 molar HCl, how much NaCl would form? So first thing is, let's balance it. And this one's actually a pretty easy one to balance it. It's just 1 straight across. And basically, if I start with 400 milliliters of HCl, how many grams of NaCl? So I'm starting here with volume, and then I'm going here and going to mass. Okay, so I have 400 milliliters of HCl. I'm going to first get that into liters, and then I know that it's 8 molar. So that's, again, 8 moles for every 1 liter, right? So that's 8 moles for every 1 liter. And how did I decide to do that? Because I need to have the liters to cancel out. Now that I have it in moles, and I'm still talking about HCl, I need to go from moles of HCl to moles of NaCl. And then once I have that, I can go from moles of NaCl to grams of NaCl. Okay? Okay, so let's go ahead and do some work with it. You ready? Let's do it. So this one right here, it's 1,000 milliliters for every 1 liter. I look at this, it's a 1-to-1 ratio, so that's kind of nice. And then my side hustle here is determining my molar mass of NaCl. Na, there's one of them, and Cl, there's one of them, and this one weighs, I think, 22.99, and this one weighs 35.45, I do believe. And so what I get here is 22.99 plus 35.45. I add those together, I get 58.44 grams per mole, and that's what's going to go right here, 58.44 grams per mole. Awesome. Last step, multiply straight across and then divide. So here I go, 400 times 1 times 8 times 1 times 58.44, and then I'm going to take that and divide it by 1,000, and bam, I get 187 grams of NaCl. And that, my friends, is my final answer. All right, so those were the notes for today. I also recorded a separate video on doing some of the problems, and go ahead and try out the homework. Thanks.